Welcome back to section 10.1. We're going to get started with formal hypothesis testing. And essentially what we want to know is we're going to use a formal hypothesis test to determine whether there is a significant linear correlation between two variables. We're going to use the following null and alternative hypothesis, and that symbol there is pronounced rho. And rho is going to be represent the linear correlation coefficient of the population, right? So we've got this sample and we want to know about how it relates to the population. So we'll always have a null hypothesis that rho is 0, that there's no correlation. And our alternative hypothesis can be that rho does not equal 0 or correlation. Now, it is possible that we would have less than 0. If we had rho was less than 0, what that's saying is that we want to know specifically if there's a negative correlation, right? If that R value is negative, or if rho is greater than 0, it would be a positive correlation. But in general, we're just really trying to see, hey, are they correlated or not? And that's why we use not equal to. So the procedure here is we're going to check the requirements, which we're going to assume are met. And then we're going to state the null and alternative hypothesis, which is always going to be this, for the most part. We're going to use technology to determine the value of R, the test statistic, and the p-value. And we're going to use the p-value, or the critical value, which we saw in the spreadsheet, to interpret what R means, and then determine to reject or fail, and then fail to reject, and restate the conclusion. So interpreting the linear correlation coefficient R, we saw this at the beginning, but here again, if we're using p-value, if p is less than or equal to the significance, it supports the claim, linear correlation. If it's greater than the significance level, then it does not support the claim. If we're using the critical values to compare for interpreting R, it's helpful to put the critical values right over here. So this would be like the negative critical value, and this would be the positive critical value. And essentially, what you're doing here is it's kind of like that curve that we used to see before. But if our R value, the absolute value, so the value of it, is in, greater than or less than, we would say correlation or no correlation. And we can find those critical values with that calculator. And we spoke about this in general. We're going to be dealing with two-tailed tests, right? We aren't necessarily looking for a negative correlation or a positive correlation. We're usually going to be dealing with just, is there a correlation? So using the value of R is equal to 0.801, and we can figure that out in a moment for the 23 pairs of data shown, use a significance level of 0.05 to determine, is there sufficient evidence to support a claim that there is a linear correlation between chocolate consumption and the number of Nobel laureates. So recall that the first thing we want to do is identify our null and alternative hypothesis. The null is that there is no correlation, right? R is 0, or correlation. So the claim is that there is correlation. So that is our claim. And so we'll type this data into our calculator. And like I said, I already did it, so go ahead and pause if you haven't done so yet. I have entered that data into my L1 and L2. And press play when you've got that in. And then we're going to go into stat, tests, linear regression t-test. This time our x is in L1, L2. Our alternative is not equal to. We're going to hit calculate. And they already told us the R. The R is 0.801, which we see here. But what we want to know here, and we'll use the p-value this time, but let's grab some information here. So our test statistic is t equals 6.123. So t equals 6.123. Our p-value is equal to 4.47 e, right? So that's 0.000, lots of zeros. So we would just say 0.0000. And our R, we already grabbed. So we know our R is 0.801. So what we're going to do is we're going to use the p-value method here to say, okay, how does the p-value compare to our significance level? So the p-value, is it less than or equal to our significance? It is. So let's go back to here. If the p-value is less than or equal to, it supports the claim of linear correlation. So we can say that there is sufficient evidence to support the claim of linear correlation. So this data is linear correlation, right? Now, just be careful here. Just because they're correlated linearly, that the consumption of chocolate and the number of Nobel laureates is correlated linearly, doesn't actually mean that consuming chocolate leads to more Nobel laureates. So just be mindful of that. Again, here's the solution written out and the interpretation. And a reminder, of course, that it would be kind of absurd to think that eating more chocolate would help win a Nobel Prize. Go ahead and give this one a try. So going through the steps just like example 2, I would recommend keeping the data in as we go forward, but that's totally your call. And press play when you're ready to see the solution. And there you go. So now we're going to use the critical values. So we did the p-values. In all honesty, we all agree that that's easier, but we're going to use the critical values. So we'll use that spreadsheet to help us. So we have new data here. So we want to know, is there sufficient evidence to conclude that there is a linear correlation between internet users and Nobel laureates? So always equality for our null. Alternative is that it doesn't equal 0, which is saying that there is correlation. So, oops, we just want to write claim there. Right, we want to know if there is linear correlation. We're going to put this data in. I'm going to put it all the way over into L5 and L6. And then I'm going to enter this data in, press pause and to enter it in, and then press play. I'll move that over when you have it entered in. All right, I've got my data in here, internet users per 100 people and number of Nobel laureates, to see if there's some sort of correlation here. So I'm going to go to Stat, Calc, Test, Linear Regression T-Test, and I believe I put it in L5 and L6, not equal to for our null. All right, so we definitely need our T-test statistic here, 2.659. 2.659. We need our p-value and we need our r. We don't really need the p-value, but that's fine. 0.056. We don't really need it because we're not actually using it, but it's always good to just kind of be mindful of it. Our r is 0.799. Okay, so now for the critical value of our calculator, which you can grab in a link on Canvas. Our sample size is 1, 2, 3, 4, 5, 6. So our sample size is 6. Our level of significance is that. So, and we are doing a two-tailed test because it's not equal to. So our critical R is 0.811. So our critical is 0.811. So what we're trying to figure out here is, and it's plus or minus because we've got a two-tailed test here. So essentially we've got, all right, so these are, imagine this is a number line. So our critical value, we've got negative 0.811 over here and positive 0.811 over here. And correlation is over here and over here. So where does the value of R fall? So R would fall, oh, so close there, 0.799, right? Like super, super, super close. That's our R. That does fall in the no correlation. So we would say, let's go over here, there is not sufficient evidence to support the claim of correlation. Let's look at our p-value here just for a moment, even though we were using the critical value method. Our p-value is 0.056. That is greater than 0.05. Not by very much, but it is greater than. So that also, says no correlation. So there it is written out for you. And you go ahead and give this one a try. And press play when you're ready to see the solution. So just being super mindful that, again, we're not assuming that correlation implies causality. And, we don't want to ignore the possibility of a nonlinear relationship. And in general, that concludes section 10.1.